This video for limit, continuity, and differentiability for students who already finished AP Calculus AB and also learn derivative. Okay, so this is for definitely for BC class, and you have to learn differentiability first. Okay, so the topics I will go over is determine the limits from the graph, and relationship between limits and asymptotes. So I'm talking about vertical asymptote and horizontal asymptote. And also compute limits algebraically and also graphically. We will talk about it. And continuity algebraically, graphically, and also relation to the limit. And discuss differentiability algebraically and graphically. Also their relation to limits and continuity. Okay. And then recognize the limit definition of derivative, which is this. This is a limit definition of derivative. We're going to talk about it here. So example, let's say they gave you this. Then you have to recognize, okay, that's the definition of derivative. And your f of x is cosine x. And at x equals a pi. So basically, this one is your f of x equals cosine x. But what is the value of f prime of pi? So that's the question. So you have to recognize by looking at this expression, your f of x is cosine x, and they ask you f prime of pi. Okay? And then we'll talk about L'Hopital's rule. So when you do the limit, so your rational expression is either 0 over 0 or infinite over infinite, then you can apply L'Hopital's rule. Okay? So those topics we will talk about in this video. So best way is before I solve this problem, you can just pause that video and do it on your own. And then if you stuck, then you can watch a video, or after you solve it, you can compare your answer with my answer. Okay, that's the best way. Number one, limit n goes infinite for n squared all over n squared plus 10,000 n. If you remember horizontal asymptote, only you take care of highest power term on the numerator and denominator. So answer is a 4 over 1, so which is a 4, so you can answer right away. But if you need to show your work, then probably what you need to do is you divide by n squared top and bottom. Then what happens is limit n goes infinite. It'll be 4 on the top when you divide by n squared. Bottom one is 1 plus 10,000 over n. Okay, so you got this. And this one goes to 0 since n goes infinite. So you end up with a 4. So you can show your work. Okay. Number 2. So this is the one shows the example. So you have to recognize, okay, this one is definition of derivative. Let me rewrite it. Definition of derivative is limit h goes to 0, f of x plus h minus f of x all over h. So this one matching with your f of x. So I'm going to say my f of x equals a tangent 3x. So they ask you, this expression is derivative of x, right? So when you take a derivative tangent, tangent is a secant square, 3x. But you have a chain rule. Derivative 3x is a 3. So answer B. Let's quickly go over derivative of trig function. Sin x, when you take a derivative, cosine x, tangent x, and 1 over sine is a cosecant, derivative cosecant x. 1 over cosine is a secant x. 1 over tangent is cotangent. Those trig function, you have to memorize the derivative. Sine is cosine x. And derivative cosine is a negative sine x. And derivative tangent is secant square. We use that one in here. And derivative cosecant x is negative cosecant cotangent x. And derivative secant is a secant tangent. And derivative cotangent is a negative cosecant x square. Okay, so those 6 basic trig function of derivative you gotta memorize. Okay, it's a definitely you have to remember this. All right, now let's do the next one. Number 3. So limit x equals to 0, 7x minus sine x all over x squared plus sine 3x. When you first step, what you have to do is you always plug it in. So when you plug in 0, 0 minus 0 over 0 plus 0, which is a 0 over 0. 0 over 0 or infinite over infinite, you can use L'Hopital's rule. So let's apply L'Hopital's rule. So limit x equals to 0. When you apply L'Hopital's rule, on the numerator, derivative 7x is a 7, derivative sine x is a cosine x. Now on the bottom, derivative x squared is a 2x, and then derivative sine is a cosine 3x, but chain rule times 3. Now you apply 0. 7 minus cosine 0 is 1. And then this one 0. 2 times 0 is 0. Plus cosine 0 is 1 times 3. So you end up with 6 over 3. 2 is your final answer. So answer is B. So make sure you don't take the quotient rule. Okay, this is different from quotient rule. L'Hopital's rule, you take a derivative numerator and denominator separate way. Okay, remember that. Now next one, number 4. Okay, so at x equals 3, the function given by f of x, they gave you that piecewise function. So now, to be continuous or not, so you have to check left hand side limit, right hand side limit. So you plug in 3 into here, you plug into 3 here. So let's see that's same value or not. So when you plug in 3 squared is 9, and then right hand side, when you plug in 3 into the second equation, 6 times 3 is 18. 18 minus 9 is also 9. So check, yes, they are same value. That means it is continuous at x equals 3. So, okay. Now, how you going to check is a differentiable? Differentiability is when you take a derivative, x squared is a 2x, and 6x minus 9, when you take a derivative, is just 6. So in the domain, x is less than 3. This domain, x is greater than or equal to 3. So now you plug in 3 into here. So 2 times 3 is a 6. And then on the right hand side, also 6, check. So since your f prime is both equal, that means it is a differentiable. So both continuous, this is continuous, and this is differentiable. Okay, and then also if it's not continuous, then you don't have to check differentiability. If it's not continuous at that point, then it's automatically not differentiable. Okay, remember that. So this case is E is both continuous and differentiable at x equals 3. Number 5, they gave you graph. The figure above shows the graph of f, domain 0 to 4. Which of the following are true? Okay, let's look at the left-hand side limit. So here, left-hand side limit, when x approaches to 2, f of x exists. Yes, when you approach to from negative side, whatever value that one, right? So I'm going to mark it some value here. Okay, that value exists. Now, so this one correct. And the right hand side also, it coming from here. So it some value exists. Let's say mark it 1, 2 for my convenience. They are different. Left hand side limit, right hand side limit is different, but both exist. So this one exists? Answer is a no. Why? Because this one not matched. Okay? If left hand side limit, right hand side limit, they have a different value, then when x operates to just that value, then that limit does not exist. So answer C. Okay? Only one side limit exists. Next one, number 6. F of x is 2x squared plus 1, then limit x operates to 0, f of x minus f of 0 all over x squared is what? So let's plug it in. Limit x operates to 0, f of x is a 2x squared plus 1 minus. What is f of 0? So you plug it in 0 into here. So 2 times 0 squared plus 1. So 0 plus 1 is 1. So 1 over x squared. So this one cancel out. Now you end up with limit x operates to 0, 2x squared over x squared. And then you can reduce x squared top and bottom, then just 2. So answer C. Okay, plug it in and reduce. Number 7, f prime of x is cosine x and g prime of x equals 1 for all x value. And they said f of 0, g of 0 both equal 0. Then limit x opposite to 0, f of x all over g of x is what? So when you plug it in 0, that's f of 0 over g of 0. So that's a 0 over 0 is set there here. So that means you can use L'Hopital's rule. Okay, 0 over 0 format or infinite over infinite, you can use L'Hopital's rule. So limit x opposite to 0, f prime of x, again, is not quotient, remember that. Just take a derivative individually. Then like this. So limit x opposite to 0, f prime of x is set at cosine x. So cosine x over g of x is 1 always. Now you plug in 0. So cosine 0 is 1. So 1 over 1 is 1. Answer B. Okay. Number 8. F of x that piecewise function, f be function defined above, and which of the following statements about f are true? So let's look at two one by one. Limit x opposed to 2 from negative side means here, this one, you plug it in. So that's ln of, when you plug in 2, 8 minus 7 is 1. ln 1 is a 0. Okay. Now you plug in 2 into the second equation here. So 4 times 2 is 8. 8 minus 7 is 1. So are they equal? No, they are not equal. Left hand side limit is a 0. This one was a 0. This is a 1. So they are not equal. Now when you take a derivative, let's see. When you take a derivative, this one. So also piecewise function. Derivative ln, let's go over this one quickly. What is the ln f of x derivative? That is the denominator just f of x, and then you multiply f prime of x, like that. Okay, so this one is the how you gonna take a derivative, the ln function. Okay. Now, so when you take a derivative the first one, so then 4x minus 7, and then derivative that 4x minus 7 is a 4. Okay. On the second one, when you take a derivative, 4x minus 7, just 4. Okay. This one when x is less than 2. This one when x is greater than or equal to 2. So when you take a derivative, that piecewise function. Now, so on the left hand side, so when I'm doing this one here, you apply 2, okay, in the first equation. So 4 times 2 is 8. 8 minus 7 is 1. Is it equal to, on the right hand side, it's just 4. Yes, they are equal. So correct. Okay. Now, is it differentiable? Okay, differentiability, it has to be continuous. So this one continuous, one of the condition is limit should exist, but limit x opposed to 2 f of x dne does not exist. So since it is not continuous, it's not differentiable. Okay, even if we have a limit for the f prime, doesn't mean it's differentiable. Remember that. So it is not differentiable because it is not continuous. So answer is only 2. You have a still limit, but it is not differentiable. Let's move on to number 9. So limit x opposed to a, f of x equals L. Which of the following must be true? Okay, limit doesn't mean limit value you have it doesn't mean it's this is a you have a derivative value. Okay, so because I'm gonna just throw one example. Let's say here, let's say there's a hole. When x opposed to a, let's say this value is L. So there's a hole, right? If there's a hole, then still limit exists, but your f of a does not exist, so it's not continuous. Not continuous, then not differentiable. So out. Continuous? No, it doesn't have to be continuous to have a limit. And then f of a is defined x equals a. It doesn't have to have a value, so no. F of a equals L? No, limit value is L. Doesn't mean f of a equals L. So answer is none of the above. Okay? So don't get confused. Even if you have a limit value, doesn't mean it's a differentiable there or continuous there or you have a value there for y value. Okay? Number 10. Now, for x is greater than or equals 0, horizontal line y equals 2 asymptote. That means a horizontal asymptote. So basically what that meant up to here, so limit x opposed to positive infinite. We don't talk about negative infinite because x is greater than or equals 0. Your f of x, it should be opposed to 2 based on this because that's the horizontal asymptote. Which one must be true? So answer is E. E definitely true because that's the definition of horizontal asymptote. Okay? So we can move on. Number 11. If the graph of y equals ax plus b all over x plus c has horizontal asymptote, okay? And also, so let me highlight it, horizontal asymptote, this, vertical asymptote, this, okay? So what is the value of a plus c? So let's talk about vertical asymptote first. Vertical asymptote means a set denominator equals 0. So x plus c equals 0, and then you need to solve for x, right? So x is a negative c. So when you compare x equals negative 3, x equals negative c, so c value is a 3. Now let's talk about horizontal asymptote. Horizontal asymptote is a y equals 2. So limit x opposed to infinite, ax plus b over x plus c. So since the highest power same term, same power, then just take the coefficient. So a over 1. That is a 2. Okay, so that means a is 2. So a is 2, c is 3. So when you add up, answer E, 5. Okay, so using horizontal asymptote, vertical asymptote, you can find out those unknown constants. Number 12, limit x opposed to infinite. So again, this is a horizontal asymptote. So I only care about the highest power term. Okay, so multiply this will give you x squared. X squared will be highest power term. So negative 2x squared. And then this time this is x squared. If you fold it out, you have other terms, but we ignore. Because that's not highest power term, then you don't have to worry about it. Now limit x opposed to infinite. So this one cancel. So negative 2. Answer will be B. And then that is also horizontal asymptote. Y equals negative 2 is horizontal asymptote. Now let's move on to number 13. So they gave you piecewise function. Maybe I need to graph it quickly, then you can understand better. Top one, when you factor x minus 2, x plus 2, all over x minus 2. And then since you have a same factor, top and bottom, so that means there's a hole, right? Removable discontinuity, we call. Hole at x equals 2. If they ask you about the location of hole, then you can say 2 comma y value is after you cancel out, you plug in 2 there. So 2 plus 2 is 4. So at 2 comma 4, you're gonna have hole there. Okay, so that's the removable discontinuity. So let's quickly graph it. So after you cancel, you're gonna have only this x plus 2 linear line, right? So then like this. So y-intercept 2, this one x-intercept -2. Now when x equals 2, there is a hole. Okay, there's a hole. Y value is 4. That's what we found out, 2 comma 4. Okay, that's the graph. Now let's talk about it. And then when x equals 2 is 1. So actually there's a dot. Okay, so now, so which of the following true? F has a limit value x equals 2. Yeah, there's a hole. So even if there's a hole, you still have a limit value x opposite to 2, then your y value opposite to 4. So it has a limit, yes. Continuous? No. There's a hole there. And then, f of 2 is 1. Is that that? And then it is not continuous. Is it differentiable? Since it's not continuous, then automatically not differentiable. So 1 only. Okay? So if you graph, then quickly graph it, and then you can answer easily. This is number 14. Now, f the function given above, and now what are the all values a and b? F is a differentiable. F is a differentiable, x equals 2. That means it should be continuous first, right? So to be continuous, you plug in x equals 2, first equation and second equation. So on the first equation, when you plug in 2, 2 plus 2b should be equal to, when you plug in 2 into the second equation, a times 2 squared is a 4a. So leave it like that first. Now, when you take a derivative, top one, 1, bottom one, ax squared, when you take a derivative, 2ax. And let me write down condition. And this one, x is greater than 2. So also by differentiability, when you plug in left-hand side, so you plug in 2, but there's a no x value, so it will be just 1. So 1 should be equal to 2ax when you plug in 2 into x, so that's a 4a. Okay, so that gives me a equals 1/4. Okay, a equals 1/4. So from here, 2 plus 2b equals 4a is 1. And when you subtract 2 both sides, so 2b is a -1, so b value is a -1/2. So answer A. So you can find out a unknown a, b constant using continuous condition and differentiable condition. Number 15. The function f is continuous for all real numbers. F of x squared minus 4 all over x plus 2. So to be continuous all x value, what this value should be? That's the question. So when you factor out x minus 2, x plus 2 all over x plus 2. So you see that this one, same factor. That's the location of hole. So there's a hole at x equals -2. So after you cancel, so let's quickly graph it. Y equals x minus 2. So -2 here, +2 here. So this kind of graph. But x equals -2. So somewhere here, -2. There's a hole, right? That hole is when after you cancel out, you plug in x equals -2. -2 minus 2 is a -4. So that's a -4. So location of hole is a -2 comma -4. Okay. So what question is, what is f of -2 value in order to be continuous everywhere? Then by the removable condition, you have to fill this one, right? That's why we call removable. Okay. So then f of 2 value should be -4 in order to be continuous everywhere. Okay. So they checking you understand what removable discontinuity. So by filling that y value, that point, you can make it continuous everywhere. Okay. Number 16. So they gave you. We call this one is a cusp. Means it is a continuous. Okay, continuous, but it is not differentiable. Okay, anything sharp corner like absolute graph, then this also sharp corner, then there is a continuous but not differentiable. Okay, so question is, what x value f is continuous but not differentiable? They talk about that cusp, so that x value is a. So answer should be a. They talk about cusp. Next one, number 17. So they gave you 1, 2, 3, all three different graph, and which of the following does limit x equals to 4 exist? Again, there's a hole. Even if there's a hole, you still have a limit value. Okay, some people they think, oh, there's a hole and the limit does not exist. No, limit value should exist as long as the left hand side limit, right hand side limit, they matches. So in this case, left hand side limit goes here, right? This y value. Right hand side limit goes here, that y value. So they don't match. So this one is limit does not exist. This one, okay. But this one, yes, you have a limit. So 1 and 2 only. But this one, since limit x equals to 4, minus, right, f of x. Let me label that. That is 1, 2, 3, 4. Is a 4. That is not equal to limit x equals to 4 positive side f of x, because that equals to approximately 2. Okay. So left hand side, right hand side, right hand side, they don't match. Okay. So that means limit does not exist when x equals to 4. Number 18. So this one algebraically, how you gonna solve for this one? So first step, always plug it in. So ln e minus 1 over e minus e, which means ln e is 1, so 0 over 0. So you can take L'Hopital's rule. When you take the L'Hopital's rule, ln x, derivative ln x is 1 over x. On the denominator, when you take a derivative, x minus e is just 1. Okay? So when you plug it in now, it's just 1 over e, answer is A. This is something else, but some students, they get confused. E squared, when you take a derivative, what is it? You know, some people say this one, oh, okay, using power rule, 2e, 2 minus 1 is 1. So that's the answer. But that is not the answer, right? Because e squared is a constant, so you have to say anything, any constant, when you take a derivative, it should be 0. So also, it was on the one of the like a chapter test in one school. Pi square, when you take a derivative, what is it? Again, this is not 2 pi. Okay, so you have to say derivative any constant will be 0. Okay, so don't get trapped. So those are any constants. When you take a derivative, you should say 0. Number 19, the graph of the function f and g shown above. What is the limit value when x equals to 1 f of g of x? So you can do this way. Limit x equals to 1 f of g of x. You can take the limit inside. So f of limit x equals to 1 g of x. The reason why I put limit inside, because you're going to do that inside first. Okay? Those we call composite function. Composite function is the way you solve is start from the inside. Okay? So limit when x equals to 1, g of x is 2 here. Okay? Don't say 1. Limit value is nothing to do with this. So then f of 2. Now look at the other value, because graph of f. When x equals 2, what is the y value? When x equals 2, y value 3. So your final answer, C. Okay? So you do inside first, and then you can find out the limit value. Now, next one is a free response. So those are one of the real free response or the previous real test. The piecewise function is given by like that and show f is continuous. So to prove it, since this is a free response, you have to show how you gonna prove it is continuous. So you have to show three conditions. First condition is a limit x approaches to 0, f of x exists or not. So let's see. Limit value, so left hand side, right hand side limit, right? So limit x approaches to 0, negative side, f of x means using this one, 1 minus 2 sine x, right? When you plug in 0 into sine x, so that's a 0. Sine 0 is a 0, so 1. Now, right hand side limit, x approaches to 0 from positive side, e to the negative 4x. So when you take when you substitute 0 into x, e to the 0 is 1 also. So they matches. So that means, yes, this is 1 and exists. Okay, check. Number 2, f of 0 exists. So when x equals 0, using this one, right? So that's a 1 minus 2 times 0. So 1. Yes, exists. Okay. Now, last condition. Limit x approaches to 0 f of x. Is it equal to f of 0? Since this value was a 1 and this value was 1, so yes. Okay. So you can say since all three conditions above met, f of x is continuous at x equals 3. Then you can get full credit. Okay, but you have to show 1, 2, 3 all condition. If anything missing, then probably you're gonna get some partial credit. Next one, number 21. This is 2012 AB, number 4, free response. Function f is defined f of x equals square root 25 minus x squared. That's a semicircle when x is between negative 5 and 5. C, g is the function defined g of x like that. So they introduce another g of x function. They make a piecewise function. Is g continuous? Okay, so to check continuous or not, so you have to first limit exists at x equals negative 3. So x equals negative 3 left hand side means this one, right? Is f of x. So limit x equals to negative 3. F of x is this, right? This one. So square root 25 minus x squared. Now you plug it in. Root 25 minus negative 3 squared. Root 25 minus negative 3 squared is 9. Root 16 is a 4. Okay. Now, what about right hand side? X equals to negative 3 from positive side. I'm using this one then. So that's x plus 7. When you plug in negative 3, so negative 3 plus 7, so that is a 4. Okay. So you can say, therefore, limit x approaches to negative 3, your g of x exists. Right? That's the first condition because they are equal. Okay. Now, second condition, g of negative 3 exists. So negative 3, I'm using this one here then. So that's same as f of negative 3. F of negative 3, plug it into f of x. 25 minus negative 3 squared, we already calculated. So that is a 4. Yes, exists. Now, the last condition, is it limit x approaches to negative 3 g of x is equal to g of negative 3. So we already computed above here. This is a 4 and this is a 4. Yes. So check. So you can say since all three conditions of continuity at x equals -3, the function g of x is continuous. Okay, so then you can get full credit. So if I label it, this one was a first condition, and this one is a second condition, and this one is a third condition, and then all three condition met, then you can say the function is continuous at x equals -3. Okay, so that's it for today. Hope that helps for your school test. So I will see you next video.